So chapter 5, Newton's third law of motion, and it is the shortest topic that we cover. And you're really going to need your purple packet. You're actually only going to need one MOP app, which is the one with Newton's laws, which is part 2. And I break this down into 4 topics, and they're all very, very short. And it's, in my opinion, the easiest of the 3 laws to understand because there aren't a whole lot of new terms that you really need to know. But it's also one of the ones that's most commonly misunderstood. So hopefully I can present that in a way that will make sense to you. So the first topic we're going to cover is identifying action and reaction force pairs. So on your student note sheet in your purple packet, starting on page 4, I've written everything out for you, so you really don't need to fill anything in. But I am going to ask you to highlight the important things and submit that as part of your work. So what is this whole law about? So it's about this idea about whenever one object exerts a force on the second object, the second object exerts an equal and opposite force on the first. Or people state to every action there's always an opposed equal reaction, or to every action there's an equal and opposite reaction. Now they're talking about forces. Reactions, when we use it commonly, we think about effects, things that happen because of something else. We're not talking about forces. However, when you state the law in this second manner, if you leave out the word forces, you really do lose some of the meaning. So let's think about what that means. But first of all, I need you to answer a question. So when you rub your hands together, when you take your right and your left hand and you rub them together, can you push harder on one hand than on the other? Why or why not? Well, I'm hoping mostly you said no. And it's because when you're pushing, you can't do more on the one hand than you can on the other, right? Because they're touching, they're just your hands, and you just can't do it. So in light of that, that's kind of the premise behind what's going on in Newton's third law. So every force is a push or a pull, and it is part of an interaction between one item and another item. So for example, you push on the wall, and the wall pushes on you. You kick a ball, and the ball pushes back on you. Car tires push on the road, and the road pushes back on the car tires. And by the way, this is what allows the car to actually move forward. While swimming, your arms push the water back, and then the water pushes back on you, and this is why you move forward in the water. So, action-reaction force pairs. I'm going to have you do a few examples here, okay? And so what you're going to do in number 1, which has a number of different parts, you're going to fill in the reaction force pair, which is here. So we've got in letter A, the action one is the head bumps the ball. So the reaction to that would be the ball bumps the head. And for letter B, the windshield hits the bug, so therefore the bug hits the windshield. Now, don't make these hard. You're really basically just switching the places of the 2 nouns. And so pause the video for a moment and finish those up. You can skip H, and you don't have to make up your own, and I'll talk about number 2 after we go over these answers. So, actually for number 2, every place there is an interaction between different items, there's going to be an action-reaction pair, and you can draw little arrows here. So where the man's hand meets the rope, there's going to be a pair there. Where the rope meets the monkey's hand, there's going to be a pair there. And then on the other side of the monkey's hand touching the rope, you're going to have another pair, and you're going to have a couple more. So looking at the answers, so A, we talked about ball bumps head. B, bug hits windshield. C, ball hits bat. D, nose touches hand. E, flower pulls on hand. F, bar pushes athlete downwards. G, balloon surface pushes compressed air inwards. And I had here a ball hits a marble and the marble hits the ball, because one year I did these examples. And if I look at all these force pairs, I've drawn arrows to where they are. So there's one at this hand, there's one at the monkey's one hand, at the monkey's second hand, at this area where there's this other force, spring force reader here, the one at the other end, and then right by the tree. So that's how you end up getting at least 6. So same concept, okay, on the next page, pages 7 and 8 for you to practice. So we're only going to do numbers 1 through 4 here. You're not going to do question 8 at this point, or sorry, question 5 at this point, because we're not quite ready there. So you've got the same thing. You've got some action force. You're going to write the reaction force. But a word of caution, sometimes students give an answer that the foot kicks the ball and therefore the ball kicks the foot. Well, last time I checked, balls cannot kick anything. So that's kind of nonsensical. So when you're doing this, be conscious of selecting a decent verb that actually will make sense, because balls can't kick anything. All right, so take a moment, pause the video, and do that. So here are your answers. We've got ball hits the bat, the car pushes the man, the bug hits the bus. Here we've got athlete's hands push the medicine ball forward, and the medicine ball pushes the athlete's hand backwards. You do not have to have the forward and backwards. You can just say athlete pushes medicine ball pushes athlete. Here we've got floor pushes the floor on the floor pushes on the foot. You can have the backwards and forwards there, and that's actually why you move, but you don't have to here. Here we've got the foot pushes the ball forward and the ball pushes the foot backward. Again, you don't need the directions here. That's not as important as recognizing our force pairs. So if you did not turn the page over and do 3 and 4, please pause the video now and do that. So number 3, true or false? As you sit in your seat in the physics classroom, the earth pulls down upon your body with a gravitational force, and the reaction force is the chair pushing upwards on your body with an equal magnitude. If false, correct the answer. Well, if the action force is the earth pulls on you, the reaction has to be you pulling on the earth. It has to be the same nouns, okay? So a lot of times people get this incorrect because they're not keeping it simple, okay, with the same 2 nouns, and one's acting on the other and the second is acting back on the first. So number 4, Shirley Board sits in her seat in the English classroom. The earth pulls down on Shirley's body with a gravitational force of 600 newtons. Describe the reaction force of the gravity acting upon Shirley. So earth pulls down with 600 newtons. So that means that Shirley pulls up on the earth with 600 newtons. So this is action-reaction force pairs, as simple as it gets. So sometimes, like we just saw maybe in 3 and 4, people get confused on equal and opposite forces and maybe try to apply them to different objects. So I'm going to leave you with this worksheet for you to do on your own, and I'll go over the answers in the next video. And this page is going to be page 9 in your purple packet. And be careful and think about this action-reaction pairs. If you're making notes as you kind of go through and keeping them simple, you should hopefully catch all the places where it might be a little tricky.